Okay, so let's start looking at different ways of assigning parameters to different data, start to analyze that, start to look at all the different ways we can use information to inform geometries and additional information. So we're going to cover a couple of the various types of parameters and data that Grasshopper uses, very much kind of just introducing you to the idea of how this information starts to talk to one another. So we'll start off looking at grids and their coordinate system, distances between points, and even size and area of different shapes. So let's start off looking at grids and coordinates. There's a couple different ways. We'll just start off from scratch. So if I go to vector, I can just start off with a single point. And we can do a couple different ways to start to actually, from one point, create a series of points. Now I'm going to go over to sets, and I'm going to go to sequence. And there's two different ways I'm going to show you, both from a series and a range. Let's start off with series. There's the first number in the series, which is going to be 0. There's the number or the step size, so essentially the distance between these points, and then the number of points. So it just defaults to these values. So if I plug this into x, I can see that I've got 10 different points with a span of 1 unit, in this case, whatever Rhino's units are, in this case feet, to create that line of points. Like I discussed earlier, there's a variety of different ways we can create some sliders for this. So maybe instead of there just being 10, I can add 15 to it. And I can start to play with how far I want this grid to go. So if I want it to kind of fit within the bounds of this rectangle, I can move the slider to fit that. So this is just creating a grid going on the x-axis. So we can see that these points are using x, y, and z. So what if I wanted to actually start to form a grid instead of just an array of points? Let's see what happens if I just plug this into here. Now it's understanding that the first point starts at 0, 0, and then it goes in these same intervals of 1 in both directions. So that's why we get an angle. That's not exactly what I want, but there's a way I can start to affect this data, and we'll cover it a little bit more. It's kind of an abstract way of thinking at the moment, but if I essentially say that I want, let's just unplug this array of points that kind of go along in this direction in that same amount of intervals, I essentially want to think of this as one pool of data, and then I want to use another set of data, something that we've referred to in Grasshopper as grafting, to add to that information. So I'm going to right click on this and say graft. Now when I plug this into here, now I've got, essentially it's taking that array and going in those same intervals in the y direction. So it's a way of kind of copying that data. Another way, you would think that, okay, now I've got a two-dimensional grid. What if I want it to be three-dimensional? In other words, going up in the z-axis. You would think if I just plug this in with that same graft, that it would do that. But in fact, it's kind of similar to before, where now it's still kind of going in that y direction, but now each one goes up an interval of z. So we don't actually want it to do that, although it is kind of an interesting way to create a slope of points. So let's go ahead and hold Control on our keyboard to unplug that. Can right click on this. If you want to add additional inputs, if you hold Shift, that creates a green arrow to add. If you want to disconnect it, you hold Control. So just remember those kind of keyboard shortcuts. So in order to go in the Z direction, I'm going to add another command to this. So I'm going to double click and type move. You can find it by going to transform this section and select move. So I'm going to take this grid of points and move it in the z-axis. You'll notice here that the cord or the string that's attaching these goes from a solid one to a dash. As soon as you start to graft data, you're essentially creating a series of different pools of data. You get this dash line to represent that. So again, it's doing it in this default of 1 or 10 in the z direction. So we want to, again, fix this. In this case, we want to flatten this. So it's all just one gigantic series of data. And we see that it doesn't really do anything until we plug a couple more components in. So let's go ahead and use the move or the z. So I want to move it in a direction. So I'll plug this into there. And right now it defaults to just once. And I'm going to plug it into here. And it kind of does that same thing where it's going to move the first 16 points up to that. But if I graft it, now I can see that I've essentially, similar to this, where I've taken that array of points and now moved it in this direction. By flattening, I've kind of grouped them all together, and now I'm grafting them in these same intervals of 0 to 15 to get this. What's interesting about this 3D grid of points is, again, I can start to change how many, and it'll all just kind of go in that same interval. If I want to change the spacing, I can do that too. So let's just try hitting 2. So now the spacing will be 2 feet between each point. So you can kind of make it less dense, but still keep that same amount of points. So these are ways of start to creating a 3D grid of points. So this essentially, the series works as assigning step values for these points. Another way of doing that is setting kind of the distance parameter between points and then determining how many points you want in between. So let's go back to sets and use range. In this case, it's asking for a domain of 0 to 1, which it defaults to, and the number of steps. So this kind of creates a distance. So this based off of starting at 0, the step size of 1, and 16 counts, it's creating a total distance of 16 feet. In this case, you can say, okay, I want you to take a designated distance. In this case, let's do 10. And then you get to determine how many points do you want to be within that distance. So I can start off with something like 15, so make it more dense. And I'm just going to replace these icons. So everything that this series is plugged into, I'm going to replace it with this one. And you'll see that it's a little bit denser. These points are closer than just one. I can make it less dense. So there's hardly any points. I can make it even more dense. If I want to change the distance, I'll just go ahead and double click to edit that. Maybe it's 20. So again, I can kind of reach out to that bounds. And then I can play with the density this way. So you can make that pretty dense by just kind of cramming as many points as possible until your software crashes. But it's an interesting way to kind of start to think about how grids can be both two-dimensional and three-dimensional. Grasshopper also has a set of designated grids that you can start to utilize. So we can start to look at these as well. So pretty much what we just created was a square grid. We can create rectangular grids. So I'm going to take all this, hit the space bar, and just hide it for now. And we can start to see that these are going up in 2 by 1. So again, the plane is just where it's starting. It's defaulting to 0, 0, 0. So we can determine the size in either direction. So 5, just kind of a random value. So now you can see that they're 5 apart by maybe they're half the size and length. So we can start to really play with what this rectangle looks like by messing around with these values. So let's just mess with this a little bit different. So let's go with, again, 2. Let's make this, maybe they're a little bit taller than they are wide. So we can play with the size of them, and then we can play with how many they are in each row. So let's, again, just kind of default it to 10. You can just copy and paste using Control-C, Control-V, and I can start to say how many I want in each direction. I'm going to add that to be 20. So again, I can kind of fill in this bounding box. So there's that. What we can also see is that it's generating cells, so essentially each one of those rectangles, as well as the points. So if I want to see the points, those are just happening at each of those corners, and they're going to be overlapping between those cells. Or I can look at the curves, and that's basically just going to highlight those same cells. What's interesting too is I can, we'll touch on this a little bit more, but maybe instead of you wanting the points of these grids at the corner, maybe you actually want the center point of this grid system. So I'm going to type area. And this component, essentially, it's going to calculate the actual area, but it's also going to assign a point in the middle too. So if that's how you want to create your grid, where it's essentially a grid within a grid, you can also use this component to add to that. Just go ahead and delete that. Let's go back to vector. Again, you can start to look at all the different ways you create a grid. So it's something that's worth testing out to see how these work. So number of grid in that radial direction, so maybe that's something like 3. Then number of grid cells in the polar direction, you can add even more. So there's a lot of different ways you can create those cells. And again, for these grids, you can see that it creates cells as well as points. So now let's look at some interesting ways to both measure distance and start to kind of organize data by distances. I'm going to take this curve and reference it into Grasshopper. Right? So what's nice is that I can actually convert this curve directly into a surface by just sticking within this geometry and select surface. So now we have our surface here. What I want to do is actually assign a bunch of random points with Grasshopper. So I'm going to go back to the vector area, go back to grid, and say populate geometry. I can just go ahead and plug it right into here, and it's going to, by default, randomly place 100 points on this surface. You can increase the number of points. You can start to make it pretty dense, make it less dense. And then you can even start to play with essentially the random seeding of this information. So depending on how it looks, you can just start to play with the seed to create all sorts of different randomized configurations of your points. So that's all you really need to mess with on this one. So in order to find a distance, it's usually good to assign some type of reference point that you're looking at the distance for. So let's say you want to just assign a random point in Rhino. I can just place that anywhere here. Take this point, reference it. So I have this single point and then all these random points. So I can basically find the distance for all of those by going to vector, point, and using distance. And this is just going to be actual data. So if you want to look at a list of information, it's good to use this panel tool. I usually just call it as a sticky note. And this is giving you all those distances between the single point and all these random points, which is kind of interesting, but it doesn't really tell us a whole lot. It's good to know, but there's a couple other things we can understand these distances a little bit better. Let's go over to curve, and basically what I can do is create a line between all those points, which starts to look kind of interesting. So again, I'm going to use a line between 2 points. So I'm going to look at all these random points along with this single point. So it's basically creating a line from all those areas. And what's interesting, again, this is all responsive. As soon as I start to move this around, it starts to go along with it. So what happens if you want multiple points? Maybe you want to just actually be able to divide, like, okay, there's this point, and maybe I want a couple other points, and I want these to basically find the shortest or associate itself with the closest point. So let's add a couple more points to this. So now I'm going to have 3 points. If I set multiple points, it's basically just going to take this one because it's the first point assigned and find all of them except for 2, which are going to get associated with this. So let's just go ahead and get rid of this. But in order to take these 3 random points that are here and find out which of these randoms are associated with it, we can use the closest point. Even though we're using multiple and you think it's closest points, it's actually closest point that we want to use. And when it's looking at this, it's looking for points to search from. In this case, it's this group of points, and then this cloud of points, which again, in this case, is just those 3. And again, it's just going to give us data for at first. It's still going to give us distance, which is cool. But I'm going to use that same component that I used before to create a line between points. And in this case, I'm using this one. Now we can start to see how they get allocated. So these points that are at the edge, it's able to determine that this one is slightly closer than this one. If I move it maybe a little bit further away, now it groups to that one. So it's an interesting way to kind of begin to associate random or a grid of points with other designated ones. So if I even start to get these really kind of close or completely move it away, everything starts to shift. Let's just can turn this off so you can see it just a little bit better. Okay, so that's an interesting way. And what's good is you can actually use this distance to assign values to these as well. So if I want to actually know that, I can go to display, text tag. I can use this as the location for these distances, the text to display, which is the distance values. And now I can start to see the distance between all those main things. We'll look at later some more useful ways of determining the distances between points and adding some other information to it. But for now, we can start to just understand how distances are utilized and visualized with text with a pretty simple script. So let's again just go now over to size and area. I'm going to do something similar where I'm going to reference this curve and convert it to a surface. And again, there's a couple different ways we can just create some random shapes in here and start to figure out their area or volume. So again, I'm going to take this, I'm going to create some random points. Okay, let's just play with that seed value. So again, I can show you how those all change. And we can move over to this mesh here and go to triangulation. And there's two ways we can just, again, create some random shapes. The first one is the Delaney mesh. So basically it's just asking for points. It's a little hard to see at first because this is a triangulated mesh, but I can see that if I look at this that there's quite a few faces. So I'm going to go to analysis and look at the face boundaries. So this is what it's actually starting to look like with that triangulation. And I can actually, this just kind of helps you visualize. If you want, you could, if they're all closed, we can start to measure that area. So I can go to area. And so again, it's creating a center point, and we'll use that later, but it's also giving me the actual area of all those triangles. So again, I can go to display, or sorry, custom preview. Oops, sorry, not custom preview. Let's go to our text, so display, text tag, location, I'm going to use the center point. I'm going to look at the text to display, which is the area. And so now we can start to see how all the different sizes compare. Again, it's interesting just seeing those numeric values, but we'll look at some different ways to look at that as well. And you can see, again, it's all kind of responsive. So as I change this, this random seeding of points, all those triangulations change, their volumes and area change in response as well. So let's look at one more way to create some random shapes. I'm going to stick with this random set of points. Let's stick with the mesh, and in triangulation, I'm going to use the Voronoi. So again, it's just looking for random points. And then it's kind of does something weird where it creates this kind of bounding box outside. What's great is that I've already got the curve. So if I look at the boundary, it might work, it might not. Perfect. So now it actually uses that curve from the beginning and creates that bounding box. And this starts to kind of create this more kind of different tiling. If you want to know how it's actually working, if I go and our 0.5, you can see that these actually just start out as circles. And as they begin to collide with each other, they begin to create these hard edges. So it's something kind of interesting where the ones that are really close, they'll create these hard edges versus areas where they're not as close. They'll kind of keep the radius of that circle, which is interesting. So it's kind of a interesting way of merging different shapes. If I just make this slider a little bit bigger until they're all colliding, that's what gives us that shape. And once you kind of reach that limit where they're all colliding, it doesn't change anything. I think I kind of like this where it's showing a variety. And again, we can use this. So again, they're just creating these planar curves. And begin to see that data. And as I change it, all those things will go along with it. So this is just a quick way to kind of look at this first series of data. Everything's going to start to build off of each other. But this is one of the areas where we can start to understand how the geometry can begin to have some data associated with it.